welcome to Parametric Equations. In this section, I'll be uh, showing you how to calculate the Cartesian equation from parametric equations, how to use trigonometric identities to solve problems, how to sketch parametric equations using Casio FX GC50, finding points of intersections, and modeling real-life scenarios with parametric equations. Right, let's get to it. Okay, as always, I always suggest my students to have a go at these preliminary questions on this topic. So I suggest you pause the video here and have a go at these before I show you the answers. Okay, here we go. Okay, the first question is asking us to rearrange and make t the subject of these formulas. Believe it or not, all these skills will be highly used in this chapter. So, how do we make t the subject of 1a? We see here that we have two lots of t. So the first step in this question is to factorize t, and once you factorize t, what you notice is that you'll have 4 minus k inside the bracket, and to make the subject t the subject, we will divide x by 4 minus k. So this will be your final answer. In the second part B, we will divide by 3 first. Both sides of the equations divide by 3 give us y over 3 and take the square root. So t is the square root of y over 3. We always put the plus and minus sign in front of the square root as well, so don't forget that. This part C, we can write 2 minus y equals to 4 log t, divide both sides by 4, and use exponential function to eliminate log. Therefore, we will have t raised to the power of, t is e to the power of 2 minus y over 4 as the power of e. Okay, in the part D here, first we can subtract 1 from x, then we divide by 2, so x minus 1 divided by 2 is e to the power of 3 over 4, if I write it like so. Then, because of the negative power of e, we can rewrite this as 1 over e to the power of 3t. Therefore, this will tell us that we can take the reciprocal of both sides, have e on top of the fraction, and rewrite that left-hand side as 2 over x minus 1, and use logarithms to eliminate e on the left. Therefore, we'll have 3t left, and logarithm on the right will give us 2 over x minus 1. Now we have to make sure that we take the absolute value, and log cannot be negative, the input of log. Finally, dividing both sides by 3, we'll have 1/3 of log 2 over x minus 1. Okay, so rewriting question 2 is asking us to write in terms of powers of cos x. So we know that 1 minus cos square is sine square times trigonometric identity. Therefore, we can replace cos square by that bracket there, and that would be done. Next, here we will have to use our knowledge of trigonometric identities. You remember that's 2 sine x cos x. Now, if we have to eliminate this sine of x and have everything in terms of cos, we will have to use 2. I'm just going to bring this, we can use square root of 1 minus cos square to be replacement for sine, and leave cos x at the end. Okay. Finally, cot is cos over sine, and to eliminate sine, once again we can use 1 minus cos square of x as replacement for sine. And finally, 2 cos x here is fine as it is. The trigonometric identity for cos double angle formula of cos of 2x is cos square minus sine square. But rather than writing minus sine square, I'm just going to write uh, 1 minus cos square again, and we can simplify the second and third term there to uh, 2 lots of cos square x and a minus 1. Okay, so that's question 2 done. Then question 3 is asking us to find the range of the following functions. Right, so we know that the log has to log here is taking any positive x values, so we start with log of 1. So, and x can only go up, so log is a positive uh, function, and it's an increasing function, so it will always increase. We know log of 1 is 0, so y will be always bigger than 0. So because of the nature of the function, that's log is always an increasing function, the y value will always be increasing as well. So part B is saying that x is bounded by 0 and pi. So we know that the sine curve will go from 1 to minus 1. Its range is 1 and minus 1. And because we have a factor of 2 multiplied by sine, therefore the range of y will go from minus 2 to positive 2. And because of the strict inequality, I'm going to use a strict inequality here. Okay, so uh, in the part C of question 3, we were asked to think about the range. The range, again, one more time, is saying that what are the y values, or rather, how far up or down in y direction does the graph cover. So looking at this quadratic equation, we are not sure how far um, we've been told the upper bound and lower bound the of the x value. So what you have to do is make sure you understand that uh, the minimum of any quadratic is found by completing the square. That means all we have to do is just half this value of 4x, put it inside the bracket. I'm sure you know how to complete the square, and subtract the square of that. So what it's telling us here is that the minimum point here is when x is negative 2. You basically take this bracket x plus 2 and say equal to 0 and solve it. And here the minimum is achieved as at minus 2. Therefore, what we are going to do is substitute a minus 2 back into the original equation to find what's the minimum value for y. Y will be negative 2 squared plus 4 lots of minus 2 minus 2. So that's a 4 minus 8, which gives us minus 4, and minus 2 gives us a minus 6. So I know that the lower value for y will be a negative 6. What's the highest value for y? Whether you can try both minus 4 and 1 back substitute that into the equation. So 16 plus another 16 minus 2 will give us 30. So, and 1 substituted into that equation give us 5 minus 2, which is 3. So value of 30 is achieved when minus 4 is substituted into the equation. Actually, my bad. Uh, minus 4 squared is 16, but here we'll have a negative 16. Therefore, here we will have a minus 2, and the value of 1 here will give us actually the higher value. So we will have y 3. So y is bounded between 3 and minus 6. So actually 1 will take us further up than minus 4. So next question uh, is saying that y is 1 over 2x plus 5 and x is always bigger than 2. So if we substitute x into 2 here, we will have uh, 1 over 9. Now, because of the fact that this is a reciprocal uh, curve here, if you think back about this value of the shape of this graph, the lowest value uh, is achieved when we have the highest value for x, and the highest value of y is achieved when we have the lowest value for x. Now, that means that the maximum here is when, well, the minimum for y is achieved when x is as high as it can be. So x value will always increase. That means that we are always going to the right, and the x is not bounded. X is only bounded at it has a lower bound of 2. Therefore, the the graph will have a cutoff point of this cutoff point is uh, 1/9. Uh, so the highest value that y can take is 1/9. So uh, we can discard the values of x that are bigger than 1/9, and when we draw the graph, uh, basically 1/9 will be here. The highest value of y will be 1/9, and uh, that means that y value is always less than 1/9. Okay, so let's look at the first few examples of parametric equations.